Welcome to the three-part webinar series on the NSHAP Advancing Interdisciplinary Clinical Research. Today's webinar is in conjunction with the GSA 2020 Annual Scientific Meeting online. The webinar is being recorded and will be posted on the GSA website. A notice to all attendees will be distributed once the recording is available. A question and answer session will immediately follow the live presentations. We will be accepting questions through the questions feature accessible on the right-hand side of your screen. So without further delay, I'll hand the microphone to our program organizer and moderator, Linda.
Hi, and welcome to this webinar on the National Social Life, Health, and Aging Project with a special emphasis on introducing all users to the data set, but topics of a special interest to clinicians. This just shows the NSHAP Investigators, and I'll tell you about the project, the National Social Life, Health, and Aging Project generally. The National Social Life, Health, and Aging Project was designed to provide information to allow researchers and policymakers to understand how the social world gets under the skin to affect health. Things like loneliness and social isolation and social networks, and also to understand how health and illness affect social functioning. Are people who are functionally limited lonelier, for example? And topical now, for example, how does the experience of discrimination increase the risk of poor health through an inflammatory process? And one of the things I'm interested in now is, does cognitive limitation damage social relationships? Many, obviously more questions, like, can poor hearing increase loneliness, which we have found is, and it's sort of obvious, yes. So the domains of inquiry in NSHAP are the social world, measures of the social world, and within each of these domains, we have multiple indicators of functioning and characteristics in each of these areas. So social, physical, and health, physical health, chronic disease, functionality. We have biomeasures, which you'll hear more in detail about during this webinar. A great measure of cognitive function, and a complete list of all the medications people are taking. We have background information on their childhood growing up, their current situation, their employment and finances, their personality, many attitude questions, and characteristics of their household and their neighborhood. The design of NSHAP is a longitudinal survey design. We began in 2005, 2006 with a cohort of, we looked for just over 4,000 people. We invited them to participate. 3,005 completed an interview. We call that our cohort 1, and that was our first wave of data with them. 5 years later, we went back to all of those people and interviewed them again. So we and you can look at change from 2005 to 2010 in almost any of the domains I mentioned before. At that interview, we also added to our sample almost 1,000 co-resident spouses and partners. They did a full interview, which gives us dyads, and it's been enormously exciting to have that insight into the functioning of the couple. In 2015, 5 years later, we went back to everyone we had spoken to before, and we added a refresher cohort of younger older adults who were 50 to 67 when we first interviewed them. We had in mind and a plan to go back to everyone this year. We should have been doing that now, talking to all of our respondents. The pandemic intervened, and we've pivoted to a more remote data collection, which you will also hear about in this webinar, which we hope to begin in June of 2021. We will re-interview all the cohort 1 people who we've spoken to before, and all the cohort 2 people, the younger cohort. We expect to have about 4,000 cases. This webinar has a format of a series of presentations on particular topics that can be analyzed with the data. There'll be 2 presentations and then a presentation on data and analytic issues, a question and answer period, which uses the questions tab on the GoToWebinar control panel, and the chats tab only for supplementary information. This will be recorded and available on the GSA website. The first session, which was on October 1st, looked at cognitive function and physical function and accelerometry, and that is available on the GSA webinars. In December 14th, the third webinar will look at medication data and dried blood spot assessments using NSHAP. And today we have 3 presentations on the topic of sensory function and remote assessment of biological and performance measures and data issues surrounding these. I want to start by introducing Phil Shum, who was with us at the start. He's the Director of Research and a Senior Biostatistician in the Biostatistics Laboratory and the Research Computing Group at the University of Chicago. He handles he's our data analysis go-to person, and handles also all of the data presentation use for the research community. We'll tell you more about that. Then we'll hear a presentation by Dr. Jay Pinto on sensory functioning, particularly sensory functioning, and obviously he's a nose guy. And then we'll hear a presentation by Martha McClintock, who has been in charge of our biological and functional measures measured directly. She will tell you about those. And then finally, we'll go to Phil, who will tell us about the, who'll tell us about the data and analytic issues. And remember, you can ask questions. So, Jay.
There we go. Thanks, Linda. I'm going to talk today, as you mentioned, about sensory function in this project, a topic near and dear to my heart. So the classical senses allow us to interact with others and the world around us. And as Linda mentioned, the whole idea of this project is to capture how the social world affects health and how people function in life. And so we are unique in a lot of cohort studies in that we have measured sensory function in older adults, and we have measured all 5 of the senses, allowing us to capture a lot of information about not only how those senses decline with age, but also how they interact with health and social conditions. So I thought I would spend the time in this webinar to go over the measures that we have so you can think about how you might use them in your own research. So I'll start with olfaction. We measured olfaction in 2 different ways. Odor identification, which is here's an odor, what does it smell like, and having people detect the odor, think about what it is, and then pick for some choices. So we did this with a validated 5-item odor identification test, which is a marker pen-based smell test called the Sniff and Sticks. It's validated. It's used clinically in Europe, and we have this across our cohort, across time. Respondents were presented with the odor, shown a picture and a corresponding word choice, and then asked to answer which one they thought it smelled like. And then we can categorize this into anosmia, or no sense of smell, hyposmia, or decreased sense of smell, or normosmia, a normal sense of smell. This is by the number of correct items. You can also use this measure on an ordinal scale. And we have this reference here in this at the bottom here, which describes the methods and how to use this olfactory assessment. We also measured olfaction in another way called odor sensitivity. This is not what is the odor, can you identify it. This is, we're going to give you different concentrations of odors at low concentration or high concentration, and we want to determine at what level you can detect these odors. So how sensitive you are to detecting the odor. This was also done with Sniff and Sticks. The odor is a standard odor called N-butanol, and we were presented these in a series of 3 pens. 1 pen had the target odor and at a series of concentrations from low to high. And then we asked people to identify which one of the pens of the 3 contained the odor. And then we score this in a very simple way also, which is how many correct answers are there for, and this is also known as threshold score. So anosmia, 0 to 2 correct, hyposmia, 3 to 4 correct, and normosmia, 5 to 6 correct. And again, you can analyze this on an ordinal scale as well. For vision, we measured binocular distance acuity at 3 meters via a standard Sloan vision chart, like you might see at the ophthalmologist. And we did this with glasses if people wore glasses, because we wanted to tell how do people function in the world, so we wanted to get their functional capacity. We did categories of vision based on driver's license requirements. So good vision, we categorized it better than 20 over 40. Moderately decreased vision between 20 over 40 over 20 over 60. And then finally, poor vision worse than 20 over 60. So we can analyze this in that way categorically, or on other ways, transformative ways if you want to look at that. And that's a very good measure of vision. Again, we have the references here for you to find to know how to score this. For hearing at baseline, we had respondent rated hearing. So we asked people, is your hearing excellent, very good, fair, or poor, or do you have a hearing loss? We added some additional questions in after 5 years in wave 2. How often do you wear a hearing aid? Does a hearing problem cause you to feel frustrated? I won't read all the questions here, but other questions about your hearing, whether you use a hearing aid and how that affects you in terms of interaction with people. We also had in waves 2 and 3, we asked the interviewers to actually rate the hearing of the respondents. So these are interviewers in the home interviewing the subject, and then they rated them from practically deaf to normal hearing. Again, another measure of hearing impairment. And finally, in the upcoming wave, as Linda mentioned, we had to pivot to remote data collection, and Martha will probably get into this in more detail. But we had people do the national hearing test, where this is a phone-based objective assessment where they call a phone number, answer some questions about whether they can hear things through noise, and that actually gives us a very good objective assessment of hearing. For taste, we used taste strips. These are taste impregnated strips of filter paper. Again, this is a clinical test that's used in Europe. And the strips are either sour, bitter, salty, or sweet, standard tastants. And we had respondents put the strip on their tongue and then ask them to choose the correct taste through one of the standard descriptors. They had a sip of water between strips, and then we score this test from 0 to 4 of number correctly identified. And this is what they look like. We also had self-reported tasteability at baseline. Again, as your sense of taste, excellent, very good, good, fair, or poor. And finally, touch. So tactile function was assessed by a 2-point discrimination, and this was done with a special device. So these are 2 little prongs. They're at different distances apart. You touch them to the patient's hand, and then you ask them, how many do you feel? Do you feel 1 or 2 prongs there? And so those are 12 millimeters, a single point, 8 millimeters, and 4 millimeters apart. And then we have a scoring system to that to determine how sensitive are they, is their sense of touch. We also collected self-reported touchability. How good is your sense of touch? And in wave 2, we also got some other issues related to touch, including how appealing or pleasant do you find the ways of being touched. So this is feeded into some of our other measures on sexuality, intimacy, interpersonal life. So those are the measures in a nutshell. And the question is, what can you do with that, and what can we learn with these data? So I'll just give you a few examples of our research and what we've learned from looking at these 5 senses and how they affect social life and health. So the first thing we wanted to do was just say we have all 5 measures in the same people at the same time. How common are these deficits, and how often do they overlap? So in many cohorts, there's a concept of dual sensory impairment or multisensory impairment, where 1 or 2 or maybe even 3 senses are measured. In this case, we have all 5, so we can actually look at all of those 5 senses. And we found some very interesting things. So this is a very busy slide, but I'll show you. We have we looked at differences by age, and then on the left, and then gender on the right. And you can see certainly there are some gender differences that are quite apparent in hearing, which more men have impairments, for vision, for which more women have impairments. And so we learned some different things about how some simple things affect it. Here you can see that deficits in essentially almost all of these areas go up with age, with the exception of taste, which is highly prevalent. Taste problems are highly prevalent in all of our age categories here. But in the others, you can see a marked increase in the amount of people who have fair or poor function as you go up in age, with hearing, with vision, with smell, and with touch. And I'll bring your attention here to the bottom left of the screen, which is, again, this is a very simple study, but I think it shows some really profound information, which is a very large number of people have multisensory impairment. So here you can see in the eldest age group, 85% of people have more than 2 deficits. So when we think about how this might impact people, we're really worried about these people who have multiple sensory impairments, who really are at high risk for having problems. Now, another thing we were able to do with these data are to look at how these 5 senses interact. And what we were really interested in was, is there an element that's in common for the aging across all these 5 senses? And so we're able to develop this concept of global sensory impairment, which is to say that we found evidence of a commonality, a common factor that underlies aging of all 5 senses. And we don't have the time to go into this concept in detail, but we want to think about sensory impairment writ large, and how multisensory impairment, or what we term global sensory impairment, is evidence of sensory aging overall. That the single factor is underlying degeneration of the senses. And they might think about that, how we think about physical frailty having some common components. We're positing that sensory aging also has an underlying framework and biology. And we can see how that global sensory impairment score predicts really important outcomes that are related to physical function and frailty and mortality. So here on the upper left, you see that as the global sensory impairment score increases, you have higher impairments in your walking speed, you have larger numbers of IADL difficulties, you have a greater weight loss, and then maybe the ultimate outcome, people who have worse global sensory impairment have higher probability of death in 5 years. So we see that sensory function is really closely related to these key factors in aging. And here's a slide of these data with the numbers. So global sensory impairment predicts a slower timed walk, more disabilities, less activity, worse cognitive function, worse overall health, greater weight loss, and increased mortality. Now, I'll zoom in on the sense of smell as an example of how one sense can be looked at in relation to some of these outcomes. So, you know, we looked at the ultimate health outcome, which is mortality. There was some kind of discrepant data in the literature about whether the sense of smell could be a predictor of mortality. It might do so because it's an ancient part of the nervous system. Your olfactory nerve is directly connected from your nose into your brain. Obviously, lower animals and even single-celled organisms use chemosensation to find food and avoid danger. And so this is a primal part of our biology. And we were able to show that those with anosmia in our data set had 3 times the odds of dying in 5 years than those with normal smell function. And this is controlling for physical health, nervous system risk factors, demographics, comorbidity, you know, a pretty robust finding. And if you compare it to other diseases that we're all interested in that affect older adults, this is on better or on the same level as heart failure, diabetes, stroke, heart attack. So this is a very, very strong predictor and even better predictor than some common things that we worry about. Now, I should mention that one way this might work is that people with anosmia are at high risk for dementia. And so maybe this is operating through dementia, and that older people with olfactory dysfunction are developing dementia and dying. And indeed, we were able to show that those with olfactory dysfunction have over 2 times the odds of developing dementia 5 years later. So this is an example of how you can do some nice longitudinal analyses with these data. We also looked at something interesting, which is, can olfactory dysfunction predict mental health? So Yazan Alayan, a talented medical student in our group, was able to show that olfactory dysfunction significantly predicts the development of subsequent depression, but not vice versa, because there's this idea of when you have a loss of sense of smell, you have decreased pleasure, and so that might increase this depression, but also depression is a disease of the nervous system. So could depression actually affect olfaction? And he was able to show, at least in an interesting interaction, in those with no comorbidities, the probability of having depression 5 years later was increased compared to those who had normal olfaction. But this wasn't apparent in people with one comorbidity, indicating that masked the effect. So I hope that I've spent some of this time here convincing you that sensory impairment has a great impact on health and life, especially for older adults, particularly as it relates to mental health, nervous system disease, and others, but also more broadly, just how it affects how people interact with the world, how people interact with each other, and how we could mitigate some of these deficits to improve the lives of older adults. So with that, I will thank you from the University of Chicago. I did want to mention to this group, as it's people who are interested in aging and sensory function, that there's this group called the Sense Network that I'm part of, which is an international network supporting research examining the role of sensory function on health and aging. We have a website. Bonnie Swenner, Jennifer Deal Franklin, and and Josh Ehrlich are trying to organize this, and we're trying to bring together people who are interested in sensory function and aging to build collaborations, generate a data hub, an information bank, and hopefully move this field forward. So I encourage people to check that out. Thank you very much.
Thank you, Jay. The next presentation And remember, send in questions. We'll have a question and answer session at the end. Next, we turn to a presentation by Martha McClintock on measuring biological and functional measures remotely. Martha?
I will unmute myself. So I titled this Biomeasures in the Time of COVID, sort of like love in the time of cholera. We were looking into the possibility of remote self-administered collection of biomeasures before the pandemic hit. Just as a way of exploring whether we could reduce costs while maintaining data quality. But then when the COVID pandemic hit, we've now moved to considering remote self-administered collection, not only of biomeasures, but also the entire project. So I'm going to tell you how we have coped with this and how we've developed measures. Let me say this is still in development. So far so good, but this is what we're doing. So in terms of the biomeasures, we have 5 domains. We have cognition. Now, some of the cognition questions will be asked on the web or in an interview, but there's some that have to be done with paper and pencil. So we'll be doing that, collecting it, asking people to collect it for themselves. The census measures, Jay just reviewed beautifully for you. We're also, we'll be collecting those. Anthropometrics or body measures, weight, waist, and possibly blood pressure we're working on. The measures of activity, frailty, for example, and then sleep, very important. And then the 5th domain is biosamples, which is collecting saliva, vaginal cytology, and capillary blood. And there are 17 biomeasures coming just from the biosamples. So there are 26 altogether that we're going for. And we've created what I have pictured here, the NSHAP BioBox, which is a cardboard box with a handle that people get. Inside it is a styrofoam box for transporting the biosamples at controlled temperature back to the lab. We then have another internal box that has supplies for self-administered touch and smell. And then most importantly is the bio booklet, which we have designed for people to use as a workbook. And we developed this in the lab first with a series of lab pilot tests to develop these self-administered biomeasure protocols. And to our delight, we found that people enjoyed having the equivalent of a junior high, self-administered science project. And based on their fabulous feedback, we kept tweaking the protocols. So they were developed over the course of interviews with 69 people. At first, there was guidance possible, but then at the end, they did it independently as they would if they were doing this at home. And 100% of the data we collect this way was scorable, which is our criteria. Then we moved into another type of pretest. This was run by NORC, and they recruited 48 participants that were experienced with being in the NSHAP study. So they weren't naive the way our lab subjects were, who were a community-based sample of convenience on the South Side. And in this pretest, which mimicked what we expect to do in the main study, 100% completed the phone interview. We got permission to send the BioBox. They consented. We sent the box and it came back. So that was very successful. To help with that success, we had 3 phone calls. First, we confirmed, did you get your BioBox? Scheduled a date for return. Then a week later, called to follow up. See, are you confused by any of it? Can we help you? And what we found out is people were not particularly interested in talking to us. It was like, yeah, we're fine. We're eager to get off the phone. And then if they didn't return the BioBox, we called again to prompt them to return it. So this is the cover of the bio booklet and contains the instructions for how to collect your own health measures and also recording the measures. We updated the cover after we went into pandemic mode by having some people here being mask wearers. So I'll now go through what these protocols look like for our 26 different biomeasures. These are the exact same domains I told you about already. And one thing that was important, I thought, was to have it color coded. So you see these colors up here in the bar, and then the tabs that were nice, heavy paper stock. So for the puzzles, which is the cognition measures, and then the 5 domains here. So it was easy to flip back and forth, and also to keep oriented using the colors. So this is what a page, I will not show you all the pages, but just to give you a feel with the color strip for the domain here. This coded the kind of bio booklet we were looking at. And the language, we spent so much time editing it down to make it be 5th grade level, a comprehension level, and to make it as simple as possible and yet clear with steps. With great help from a graphic designer in thinking a lot of this through. So here's an example of one of the paper and pencil tests. What you do is you start at 1. This is an example that's printed. You go to A. This is a trails test. Then you go to 2. Then the correct answer would you go to B. Then you go to 3. Then you go to C. And you just draw out the pathway until they reach the end. So of the 3 puzzles that required paper and pencil, 100% of them returned scoreable data in our field test using the BioBox. Then the next section are the senses that Jay told you about. So you'll recognize the smell pens. Here's the taste strip. Vision chart, ways to attach it to the wall. We use touch wands, which are plastic wands with a fiber filament of different diameters and therefore stronger touch on the finger. And we said for this that they needed to recruit a helper to run the test, because you can't be looking at the wand to know whether or not it's touched you. We wanted just the straight up touch. So here's an example of a close-up of the smell pen instructions. And then this is what the answer sheet looked like. Jay mentioned this, where pen number 1 smells like, and you just check the box with both the word and the picture. And of all the senses that Jay told you about, we got very good scorable data in all but the optional phone call for the national hearing test. And that was administered at the different point of the interview. We're going to try moving it up and see if we can't get responses that are on a par with our other sensory measures. But we do have self-rated hearing as a backup. Now we have the body measures and supplies. This one they could keep. Weights tape measure. Again, excellent scorable data. And then come the biosamples, which are a challenge. We sent this styrofoam box. I showed you that in the first slide. And we had them put the styrofoam box in their refrigerator. And then we had them take this very good ice pack, better than your going on a picnic ice pack in your cooler, to keep it in their freezer to be ready to ship it back to us. So we asked them to keep the styrofoam box in the refrigerator, freeze the pack until they're ready to ship it back to us. And then this shows you how the Evelyn brush, and that I'll get to shortly, and the saliva sample fit into that box very nicely. Here's the saliva sample. They take off cap A, then they insert the ribbed end into this vial, and then they have a guide here, a saliva guide. So they hold that assembled up to their mouth and then drool passively. No spitting, clearing your throat, just passively drooling. And from that, we measured steroids, or measuring steroids. When they finished, that went into the refrigerator. Then we also collected, and we're unique in this, a measure of vaginal cytology. It is a fabulous bioassay for reproductive hormone levels in women. And so when we collect the cells with this device, we then take the cells under the microscope, first stain them, and then under the microscope, we can get a measure of this. Now, when we had field interviewers, they gave them just a simple swab, and the cells were collected that way. Here we have a device that's designed for self-collection. It's been used widely in Europe. And so the woman inserts this part up in her vagina to the wings, and then pushes in the plunger. There's a brush inside here that comes out. She spins the plunger. It's it's painless, and it's very simple. And when they're done, they pull it back in so it retracts, and pop on the cap, and again, put it in the styrofoam box till they're ready to ship it to us. The last are blood samples, and we considered using what we've done before, which is the Whatman 903, where you take a lancet and lance your own finger and then drop blood onto the pre-printed circles of the Whitman 903 card. But there were many people who said they just didn't think the older people in our representative sample of older adults in the US would be willing to do this. So we ran a self-pilot where we tested 4 different devices for collecting dry blood samples, and we've settled on this Tasso device. Its advantage is that it is virtually painless. Most people don't feel anything. It attaches to your arm with adhesive. You push this red button, big red button, and then you can see here the blood flows down into these volumetric tips that are designed to hold a very precise aliquot of blood. So this is an open cassette that shows you the 4 tips that have been filled with dried blood. So we're currently working on developing those assays. We have a SARS-CoV-2 antibody test that we've successfully run on this and reported our results back to people in our self-pilot. So in summary here, of the saliva, 92% of people returned the saliva sample, and of those, 96% were assayable. As we found, same percentage as in person, 77% of women agreed to give us a sample. And in our blood microsampler pilot, 100% returned actually 4 devices with blood. And at the moment, 88% of those samples were assayable. So we're working on increasing that. So altogether from these samples, we have 17 measures of sex and stress steroids. From the vaginal cells, we have estrogenization, as well as the microbiome. And then the blood sample will be collecting SARS-CoV, it should be 2 antibodies, Epstein-Barr virus antibodies, A1C, which you'll hear about next set of presentations in December, hemoglobin, CRP is a measure of inflammation, and then lipids. The last thing is fitness. This is a fabulous device that is sensitive to movement in 3 dimensions, X, Y, and Z. And we have people attach it to their leg with this stretchy bandage, which is actually used by vets for horses. So it's a nice big bandage. It sticks to itself. It does not stick to clothing or to skin. And the participant straps this onto their leg. And then they do the test. So one of them is chair stands. And you can see here the signal in all 3 dimensions of the 5 chair stands. And with these data, we can look at how many they actually did, the speed and the steadiness. While they're wearing the watch, they move, or the actigraph, they move it to their wrist. Here they raise their arm 3 times just to show they're starting. And then we ask them to walk for 6 minutes. So here are the data that can be used to determine the speed or the distance covered while they walk. And so far we have 87% of people returned a fitness tracker, and of those that came back and used, 100% of them were scoreable. So we have 26 remotely collected biomeasures that people self-administered in their homes. On average, it was a 91% return rate, and of those that were returned, 98.9% of the data is scoreable. So potential uses, it could well, as a methodology, facilitate telemedicine. I'm not saying it would replace in-person visits, but for people who live in rural situations or limited mobility, they could collect lab results on diabetes, immunity, steroids, also measures of sensory function that Jay told you is so important, home measures of frailty, activity and sleep, cognition, and anthropometrics. But the really exciting thing for me is interest in understanding how biology is regulated and affected by social lives in the mind. And so these biomeasures are embedded in a really rich, broad data set that includes social lives, health disparities, intimate relationships, mental health, and a variety of other things. So I'll just end by acknowledging people who've made this possible, and thank you very much.
Thank you, Martha. Next, we go to Phil Shum on issues of data and analysis for these measures and similar measures. Phil?
Oh, that might work better. Apologies. Thanks, Martha and Jay. I hope that based on their two presentations, everyone is excited to use our sensory function data and the Biomeasure data that we will be collecting remotely. I'm going to do this very quickly because I do want to leave a few moments for questions. So I'm going to just simply make a few comments on sort of the data and some related analytic issues concerning the items that you've just heard described. With respect to sensory function, as you saw from Jay's presentation, prior to 2021, we did a lot with sensory function. However, those items were administered, some of them only in selected waves and to certain random subsets of respondents. And so the first thing for you to do if you're contemplating a study using the sensory function data from NSHAP prior to 2021, the data that we have collected thus far, you need to simply look and make sure you understand sort of when and of whom the items were asked. As a result, we do have somewhat limited longitudinal data. The richest longitudinal data we have is for olfaction at the moment. However, going forward, our intention is to beef this component up. I would point out that there are a number of self-report measures of sensory function that I think Jay alluded to, in addition to the objective measures, and those can be very helpful, either because you can model them sort of jointly with the objective measures, or you can use them for multiple imputation in persons without the objective measures. So those are definitely worth considering. And then finally, it's very important to pay attention to reasons for item non-response here. One of the best pieces of advice I can give you is to look sort of at the progression of response to items for a given measure. So for example, with the olfaction, you can occasionally see a person who gets 2 items wrong and then refuses the last 2, which, when you sort of look at it, think about it, almost certainly indicates that they gave up because they couldn't smell anything. And so that's something worth paying attention to with respect to the data. As far as analytic issues here go, the simple scores for a lot of the sensory function measures, basically just the sum of the items that are correct, actually work pretty well. I mean, statisticians can find out all sorts of things that are sort of problematic about them, but the reality is, when you actually look at it, often they capture a lot of the information. You should definitely use an ordinal model when you're analyzing those as an outcome. Don't split them or dichotomize and lose information. And then when your sensory measures are actually the covariate that you're interested in, you should consider very carefully the impact or the implications of measurement error. Our sensory measures are actually very good, but there is measurement error there. You know, we're limited in an omnibus survey. We can't administer a 20-minute olfaction assessment, and so that will tend to it'll tend to affect your power, and it'll also tend to bias coefficients downward. You can fit item response theory models to these data profitably. We've done quite a bit of that. One thing you need to think about there is you need a guessing parameter, because for example, our olfaction items essentially are a multi-choice sort of thing where one of them is correct, and so you have to account for the fact that people, you know, will occasionally get that right just by guessing. And then finally, I would just say, if you're considering doing longitudinal analyses on the olfaction or sensory function data, more generally, you typically want to avoid just computing change scores, partly because they're subject to really strong edge effects. Most people get the olfaction items correct, and there's sort of a tail to the left among persons who have some kind of deficit there. But when you start subtracting them, you do kind of funny things. Much better to actually, in all cases, if you're looking at longitudinal sensory function data, to fit a model to multiple time points simultaneously, and to actually compare then on the scale of the linear predictor. So what I mean is, for example, you know, if you're fitting an ordinal logit model, do the comparison on the scale of the linear predictor, not the probability of getting one of the categories correct. And then, you know, obviously, in the case where you have 3 time points or more, and we do have that among some people for our olfaction data, you can fit a random slopes model. However, even in the case where you only have 2 time points, you can still use appropriate interaction terms to determine whether change in olfaction is actually related to a particular covariate of interest. With respect to the self-collected remote biomeasures that Martha described, I'll just say a couple of things. The first is, you know, we're quite aware that there's a lot of additional metadata that we're going to need to provide as we distribute these data, to allow you to really get a sense of what went on in the home and how much do we know about it. And so we absolutely plan to do that. We do anticipate some more item non-response. So the box that she showed, we're going to try very hard to get as many of those back as we can. And so if somebody simply failed to complete one of them for whatever reason, one of the measures, we obviously vastly prefer to get the whole box back, rather than you know, wait for them or have them not return it because they can't complete that one measure. At any rate, you know, the missing at random assumption here, namely that conditional on all the covariates you observe, that non-response is missing at random, that you need to think about that very carefully here, depending on how you're going to sort of deal with that item non-response. And the one thing I would point out, I'd like to point out actually 2 things here briefly. You know, Martha sort of mentioned that COVID maybe pushed us in all in on this remote collection, but we've been considering it for some time. And there are many benefits that this will bring to NSHAP going forward, even apart from COVID. So while in some cases, you know, this may represent a bit of a compromise over what we would do if we were in the home, in many cases, it may well not be. So for example, the accelerometry measured frailty assessments, they may well be more accurate than the interviewer timing with a stopwatch, which is what we had done in the past. And to the extent that we can collect these successfully, these also will allow us to go back to people much more frequently. And so one of the things with our biomeasures in NSHAP, which are collected every 5 years, people often ask if we can collect them more frequently, and this indeed will allow us to do that. One of the questions I'm going to answer already that somebody has asked about sort of validating the in-home or the self-collected biomeasures versus the interviewer collected. We are presently doing this. and with the intention of being able to harmonize those measures. We are this fall currently actually conducting an expanded pilot study. This is beyond the pretest that Martha showed on about 400 individuals, and we'll use those data in conjunction with the data we collect in 2021 to sort of validate these self-collected measures and, when necessary, develop a harmonization for them. The item non-responses I mentioned before can be handled by multiple imputation here, and we have very rich data, not only the self-report clinical data, of course, but all of the biomeasures from previous waves as well. As I said before, again, non-response you have to think about very, very carefully here, and I think two-stage models often I think are going to be more appropriate here. And then just finally, for those of you thinking of doing longitudinal analyses on these biomeasures, the remote biomeasures, our intention is to provide harmonized measures so that you can do kind of straightforward standard analyses with these. But if you want kind of maximum flexibility, you may well have to incorporate a measurement model into that. And we will be providing guidance for that as we release the data. So I'm going to stop now, and I think Jen, hopefully we have time for just a few more questions. Thank you very much.
Thank you, Phil. And now we'll turn to questions that will be moderated by Jennifer Hannes-Martin.
Yes, we just have a couple of minutes. We had several questions come in, and if we don't have time to respond to your specific question right now, we are going to be putting the information together and making it available on the webinar site as a handout, and we will respond to you individually at your email addresses. One of the questions that came in, can you share why NSHAP selected the 4 particular items from the hearing handicap inventory, the HHIE, for inclusion in wave 2? For example, does a hearing problem cause you to feel frustrated when talking to members of your family? The validated screening version has 10 items. That's for Dr. Pinto, of course, sorry.
That is a great question. I think we picked the items that we thought were most pertinent to the kinds of analyses we thought we were going to be doing and what other people would be interested in. And I can provide a more detailed answer specifically to you.
Another question that came in is, do you have any pilot data showing the comparability of home versus interviewer administered sensory tests?
Yeah, Jen, I tried to answer that.
Thanks.
We're collecting that right now as part of this expanded pilot study this fall, and we will make those data available as soon as we sort of have them and have analyzed them.
Thanks.
We also did that in our initial 69-person, lab tests. So we have some data there as well.
Thanks, Martha. Another question that came in is, can sensory loss be reversible? Are there any preventative interventions for sensory decline?
That's a great question. So for sense of smell, there is an intervention called smell training or smell therapy, where people smell odors in the morning and the evening in an effort to stimulate the olfactory system. That's shown some promise in mitigating, reversing some forms of smell loss, and that's an example. There are some trials underway now to see if mitigation with hearing aids could impact the effect of hearing on cognitive dysfunction. So that would be a way of at least mitigating hearing loss, the function of hearing. And I should mention that cochlear implantation is a way of curing hearing loss by putting an implant in that takes over function of the cochlea and the auditory nerve. So there are some ways of doing that, and we have to think creatively of others. Simple measures such as removing cataracts to improve vision, or glasses, or LASIK. I mean, there are some basic things that you can do to improve sensory function for people, or at least block its effects. And we have to see how well those interventions work on some of the outcomes that we're interested in.
But I think it's important to realize that's a huge health disparity and has to do with financial coverage of a lot of those interventions.
Thank you, both of you. There is a handout. If you look under the tab handouts, if you haven't looked at that yet, please do. There are many resources online for NSHAP that you can access that can answer additional questions. There were 2 questions we didn't get to that I will happily make sure that we follow up with soon after.
Great. On behalf of the Gerontological Society of America, thank you very much for your participation today. We hope you can join GSA on November 4th to the 7th at the GSA Reimagined 2020 Annual Scientific Meeting online. The meeting will be hosted on a state-of-the-art platform that will offer an immersive experience, allowing you to focus on essential research and networking. Thank you again for participating. This is the end of the program.